Hello everyone, this is Dr. Suman, Associate Professor from the Department of Civil Engineering, AJIT, Mangalore. Today I will be dealing with the numericals of analysis of trusses. So we'll take up the first problem, that is analyze the truss in figure by the method of joints. So this is the truss given, and here is the roller support, a triangle, and the rollers here with the hashed surface represents a roller support. You have seen in the chapter of supports and reactions. So here this is the pinned or the hinged support. So you need to know how many reactions will develop for a roller support and for a hinged support first. So applies those reactions. For a roller support only one reaction will appear, whereas for a hinged support there are two reactions developing here. If the point is F, that is RFX, and here it is RFY. And then you check how many members are there in a given truss. Count how many members are there. That is 1, 2, 3, 4, 5, 6, 7, 8 and 9 members are there. So M is nothing but members. J is joints. See how many joints are there. 1, 2, 3, 4, 5, 6. So 2 into 6 is 12. 12 minus 3 is 9. So left hand side is equal to right hand side. That means the given truss is statically determinate. Sometimes they may ask you, check whether the given truss is statically determinate. So you should know this. So if it is a statically determinate truss, then we can solve it by applying the conditions of equilibrium. So next, after drawing the reactions, after knowing how many members are there, you need to know that for what arrow marks I have drawn here, these are nothing but showing the tension force in the member. That is remember the force here in each joint. I have represented only for 3 members. In each joint the arrow mark should be pointing outside, showing that there is tension in each member. So in all the joints the arrow mark will be pointing outside. Now first, before going to the joints, we have to solve these unknown reactions RA, RFX and RFY, for which you have to apply the conditions of equilibrium. So what is the condition of equilibrium? Summation f of x is equal to 0. So what are the horizontal forces acting on the truss? Only one is there, RFX is there. That is RFX moving in the negative x direction. So it is minus RFX. Any other horizontal force acting on the truss? No, only vertical forces are there, right? Only vertical forces. So RFX becomes equal to 0. So this is 0. Next condition of equilibrium, summation f of y is equal to 0. So take all the vertical forces, RA plus RA minus 1000 plus RFY is equal to 0. Further simplify this equation, you will get RA plus RFY is equal to 2000. Name it as equation 1. Next, take the moment of all the forces about point, third condition of equilibrium, about point A or point F. Any point you can take and find out what is this RA and RFY. So how do we take the moment about the point A? That is 1000 into 3 in the clockwise direction. So it is plus 1000 into 3. Again clockwise with respect to A, plus 1000 into, what is the perpendicular distance? 3 plus 3, 6. 1000 into 6 Next force is RFY acting in the anti-clockwise direction with respect to point this. So it is RFY into 9 in the anti-clockwise direction. So it is minus 9 into RFY. Therefore RFY is equal to, simplify these two, you will get 1000. Substitute this RFY in this equation. Equation 1, you will get RA as 1000. Now you have found out RA, RFY and RFX. Okay. Now we can move on to the method of joints to solve the analyze the truss. Means we have to analyze in each member what is the magnitude of force and what is its direction, whether it is a tension force or whether it is a compression force, we have to find out. So first take the joint A. I told you in the steps, first you should know in which there are less number of unknown forces or unknown members. That is, here there are only two, FAB, FAC. We have already found out RA. It's better to go for joint A compared to joint B or joint C or any other joint. In this F also it is lesser, only 1 and 2 unknown reaction, because these you have already found out. So after finding out, I have put it here. Now take this joint A. Okay. Here in the joint A you have 1000, that is what you have found out the reaction RA 1000. FAB, see what I am talking about, tension always is arrow mark pointing outside. Okay. FAB, FAC. How did I get 45 degree? See, they have given you this as 3 meter and this height as 3 meter and this as 3 meter. So tan theta here is nothing but 3 divided by 3, which is equal to 1. Theta is nothing but 45 degrees. So I found out that this angle is 45. If this angle is 45, this is 90 degree obviously. This is also 45. If this is 90 degree, find out what is this. Put tan theta here. You know this distance, you know this distance. Likewise, you can find out all the angles. However, here since both the sides are equal, all the angles you will get it as 45 only. But in some other cases you will get different angles. So you should be very careful in calculating the angles for each joint. So here you have got it as 45 degree. This is FAB. Apply the conditions of equilibrium. Summation f of x is equal to 0. First condition. For this particular joint, apply this condition. Summation f of x is equal to 0. Here, which are the forces in x direction? FAC, moving towards positive x direction. So it is plus FAC. FAB, making an angle of 45 degree with the x axis. So it is FAB cos 45, moving in the positive x direction. So it is plus FAB cos 45, which is equal to 0. Okay. Both are unknown over here. Apply the second condition of equilibrium. Summation f of y is equal to 0. Summation f of y is equal to 0. 1000 moving in the positive y direction. So it is plus 1000. FAB in the y axis, it will become how much? Along x it was cos, along y it will be FAB sin 45 degree is equal to 0. No other force in the vertical direction, which is equal to 0. Therefore FAB is equal to minus 1414.21 Newton. What did I say when we get a minus sign? It means it is in compression. Negative sign indicates that the member AB is under compression. Like if the arrow mark is pointing outside the joint, that means it is in tension. What we assumed when we started the problem is FAB has tension. From both the joints it is coming out force. Now here we found out that it is not tension whereas it is compression because of the negative sign. Okay, FAB is negative. So use the same sign and use the same sign and solve for AC, because here we are not going to change the sign in the joint A. So use FAB is equal to minus this much in this equation and find out what is FAC. You found out FAC is tension. Our assumption is right because you got positive 1000. So FAC, for FAC, no need of doing anything. Take it directly this value only. Whereas FAB, since you have got minus now, when you consider the next joint, you have to consider the direction opposite. That is, initially it should have been going outside, even from the point B, arrow mark should have been outside, tension. But since you found out that AB is in compression, please change the arrow towards B in B direction. Now don't get confused that A arrow mark was pointing towards B only. Yes, it was pointing towards B, but from B joint, how it was showing? From B joint, it was showing outside. Now we found out that the arrow mark shouldn't have been like this. It should have been in the opposite direction. That means this also should be in the opposite direction. So now where it is pointing? Towards B. That is what you have to represent here. It is towards B. Okay. So FAB is towards B, you should write down. The other two you do not know. FBD and FBC you have not solved for. You do not know what is the direction. So still assume that it is in tension. It is moving outside in all the direction. It is moving outside. Okay. So next, considering the joint B. I have considered the joint B. Sorry. We have already found out AB is in compression. Assume BC and BD are in tension. Now apply summation f of x is equal to 0. That is FBD plus FBD. This is in y direction, no considering in the x, summation f of x. So this one FAB, it's making an angle of 45 degree with the y axis. So along x it will be FAB sine 45. Since it is moving, when you put this along the x axis, resolve it along the x axis, it will be FAB sine 45 moving towards the positive x axis. So it is positive. So you know what is AB. Now here you have already changed the direction. Okay, the arrow mark you have already changed. So don't go to put here minus again. Put it directly the value 1414.21 in the value of AB, and you will get FBD as minus 1000 Newton. Again you got FBD as negative. You have taken it as tension force positive. But you found that minus 1000 Newton. So in this particular problem, still you will take it as minus, whereas when you go to next joint, you will change the arrow mark in that joint. Okay, that is when you go to joint D. Okay, so now after applying summation f of x is equal to 0, next apply summation f of y is equal to 0. Summation f of y is equal to 0. This is in the y direction, minus FBC and FAB along x axis. It is, sorry, along y axis it is this arrow mark. Along y axis it is moving towards the positive y axis. So it is FAB cos 45 with the positive sign. So FAB here also directly substitute the value. Okay. So FBC also you got it as 1000. You got it as positive 1000. So the force is tension. What we have, assumption we have taken is correct. Next, moving on to the C joint. C joint. In the figure you see C joint. That is, there is a force FAC. Consider it as moving outside. BC, CD, CE. These many forces are there. Okay. So, considering the joint C, FAC is there, FBC, all are tension force I will consider. Also there is 1000 Newton force acting at the joint C, even that you should consider. Here all the forces I am assuming tension, so it is moving outside the joint C. Okay, and also there is 1000 1000 Newton force acting downwards. Okay. Next, apply the conditions of equilibrium. Summation f of x is equal to 0. That is FCE minus FAC plus FCD cos 45 is equal to 0 in the x direction. But we have found out AC as 1000. Further simplifying, you will get this equation. Next, apply f of y is equal to 0. F of y is equal to 0. FBC, okay, FBC, we have already found it as 1000 Newton, so applying 1000 Newton here. FBC plus 1000 minus 1000, and along y direction FCD sine 45 moving towards positive y direction, so it is plus FCD sine 45. But what is plus 1000 and minus 1000? It becomes 0. So FCD becomes equal to 0. 0 force member. So your FCD, this diagonal member, is a 0 force member. Okay. Next, substitute this CD value here and find out what is CE. You got as positive, so our assumption is right. It is in tension. Okay. Next, moving on to the joint D. Here it is written as B. Please consider this as D. Ignore this sentence. So we are taking the joint D, in which we have to apply the conditions of equilibrium. Summation f of x is equal to 0. That is FCD along x axis. It is first is FBD plus FBD plus FCD sine 45. Along x axis it becomes sine because it's making angle with the y axis. FDF along x axis it is sine 45 degree, which is equal to 0. No other forces in x direction. Now substitute the values we have found out. Okay. And FBD is, we are supposed to find out FDF. FBD we have found it as 1000. Yeah, please note here, it was 1000. So we have changed the direction over here. If FBD, if it was positive, we had assumed it to be moving outside. Now we found that FBD is negative. Okay, FBD is negative. That is why we have changed the direction and it is moving inwards to the joint. If we have assumed it as tension, then it should move outside the joint. Now because we got FBD as minus 1000, we have to change it inwards to the joint when we solve it for the next joint. Okay, so we'll get applying BD as 1000, directly the value you apply because already you have changed the direction inwards, plus FCD, CD we know it as 0, this goes off, DF you find out from this minus 1414.21 Newton. Since it is minus, it is in compression. So we also found that FDF, this is also, we have assumed it as tension moving outside. So now it is moving inwards. When you consider the next joint, you should consider. Here directly take the same negative value and substitute in the equation here. Okay. Next is summation f of x you have put, summation f of y is equal to 0. FCD along y axis is moving towards the positive y axis, arrow mark is heading upwards. So it is plus FCD cos 45 degree. FDF moving towards negative y direction. When you are resolving it along y, it is minus FDF cos 45 minus FDE, which is equal to 0. This term will be equal to 0. Now substitute the value of FDF, what you got here, including the negative sign, substitute here, you get it as 1000 Newton. So since it is tension, you got it as positive, it is in tension, that means our assumption is correct. Next, moving on to the joint E. In joint E, we assumed CD are in tension. We found that AC is here. In the joint F, we have which all forces? FFD, FEF, RX, RFY. These are the forces acting. So these are the forces acting. Apply the conditions of equilibrium. Summation f of x is equal to 0. That is FEF minus 1000, which is equal to 0. So FEF, you found it as 1000 Newton, which is in tension. That means our assumption is right. Okay, we have almost finished all the members. So now put a tabular column. How many members are there? 9 members are there. Write down each member and go on filling the magnitude force of each one. Whether it is compression, whether it is, there is a type, which type of force is that, whether it is tension, go on filling in the tabular column, looking into each of the joint. Okay, so this is how we analyze the trusses. So work it out by yourself, considering each joint, that then you will be able to understand it better. Okay, we'll move on to the next problem, that is analyze the truss in the figure by the method of joints. The given truss is, whether it is statically determinate or indeterminate, how will you find? M is equal to 2j minus 3. Count how many joints are there. 4, 5 plus 3, 8 joints are there, and members, 13 members are there. So M is 13, which is equal to 2 into 8 minus 3. You will get it as 13. So it is statically determinate structure. You can apply the conditions of equilibrium and solve for this. There is a hinged support here and a roller support here. So for a hinged support, you have two reactions developing, RAX, RAY. For a roller support, only one reaction in the vertical direction, RHY. Now for the entire figure, please apply the conditions of equilibrium and find out these unknown reactions. Summation f of x is equal to 0 for the entire figure. RAX is the force acting in the positive x direction. So RAX, there is a 3 kilonewton force acting in the x direction, positive x direction. So it is plus 3 is equal to 0. Therefore RAX is equal to minus 3 kilonewton in the opposite direction. So that means RAX, we got it as minus 3 kilonewton. Next, we'll apply the condition of summation f of y is equal to 0. Summation f of y is equal to 0. RAY, RHY, minus 4, minus 10, minus 5 is equal to 0. Next, by this we couldn't solve RAY and RHY. So we'll take the moment about the point A, third condition of equilibrium. Moment about the point A, when I take these two forces passing through, reactions passing through point A, cannot take the moment. Moment produced by 4 kilonewton, which is at a distance of 4 meter, is moving clockwise with respect to point A. So it is 4 into 4 plus 10 into 8 plus 5 into 12. 3 kilonewton is at a distance of 2 meter from point A. The distance is 2 meter. So the line of action of this 3 kilonewton is here. It is at a distance of 2 meter. So 3 with respect to point A, it is anti-clockwise direction. 3 into 2 minus 3 into 2. The other one reaction remaining here is RHY. With respect to point A, it moves in the anti-clockwise direction. So it is minus RHY into 4 plus 4, 4 times 16 into 16. Therefore, RHY is equal to 9.37 Newton. Substituting RHY here, you will get RAY as 9.63 Newton. So we found out the unknown reactions RAX, RAY and RHY. So now here we had assumed the RAX in this direction, correct? But the answer we got here is minus. Okay, minus 3 kilonewton. What does this mean? It means that RAX shouldn't have been in this direction. It should have been in this direction, opposing in this direction. So when I take the joint A, see, before going whether I decide to go for joint A for solution or joint B, please see where there are minimum number of unknowns, FAB and F, only 2 unknowns here. These are already found out. So that is why you choose A. Now when I go to joint A, since this I have got it as negative, I will reverse the direction of RAX. So RAX, I will put it in this direction. Okay. Then FAB, FAC. How FAB, FAC? Because the force in the member FAB, FAC. Making the angle. Find out this angle. What is this angle? This is 2 and this is 4. Accordingly, find out this angle. Tan theta you apply and find out what is this angle. 26.57 is the angle between this. Likewise, please find out the angle between all the, if this is 26.57, find out this angle, find out this, all the angles you find out, because you are having the sides. Just by applying the tan theta, you can find out all the angles, and we require it when we go for each joint. So please solve it and mark it over there. Joint A, FAB, FAC. So remember our assumption, all the forces are assumed, in all the members the forces are assumed to be in tension. That is why the arrow mark will be outside. Okay, you need to remember this. Summation f of y is equal to 0. Summation f of y is equal to 0 when I apply FAC, moving towards the negative y direction, minus FAC sin theta, okay, plus 9.63, moving towards positive y direction. So FAC, I find it as, applying this angle 26.57 degrees, I get it as 21.53 kilonewton. Now apply summation f of x is equal to 0. FAB minus 3 plus FAC cos 26.57 degrees. So simplifying for FAB, I get it as minus 16.27 kilonewton. That means my assumption is wrong. I should have taken it as compression. So when I move to the joint B, I should not joint B here. When I move to FAC, I found it as negative, right? FAB is found as negative. is found as negative. So when I move to the joint B, I should take care of the arrow mark. So for this it is solved. Move to the joint B. Instead of the arrow mark moving outside, since I have got this as negative, I'll put it as moving in the compression side. Okay. Then in joint B, what other forces are acting? There is a 4 kilonewton acting here. Then there are two more forces, FBC and FBD. So FAB also is there. So please apply the conditions of equilibrium. Summation f of y is equal to 0. Minus 4 minus FBC is equal to 0. FBC is minus 4 kilonewton. So it is not tension. Even this is compression we found. Use the same minus 4 kilonewton in case you need in summation f of x. Put summation f of x is equal to 0. This is simple. FAB plus FAB plus FBD. No other forces. So you know what is AB. AB you got it as minus 16.27, but since here you change the direction, use only 16.27. Substitute in FAB 16.27. Therefore FBD is equal to minus 16.27. You will get, see, you substitute FAB directly 16.27. So plus 16.27 plus FBD is equal to 0. So FBD is equal to minus 16.27. It is in compression. Okay, it is in compression. Next, moving on to joint C. Where is the joint C? Joint C is here. So where you have FAC, FCB, FCD and FCE, all moving outside. Whereas how much is AC we found out? Positive. So all the forces are moving outside except for FBC. FBC, how much did we find out? FBC, we found it as negative, correct? So instead of moving out of the joint B, it should move in for joint B. Likewise, it should move in for joint C, because we got it as negative. Otherwise, from the joint, all the forces would have moved outside if it was in tension. So now this arrow mark will be moving inside joint C. Okay. Now apply summation f of x is equal to 0 for this figure. So you have FAC along x-axis minus FAC cos 26.57 degrees plus FCD cos 26.57 degrees. There is one more force in x direction, FCE plus is equal to 0. Now FAC you have already found out in the previous slide, 21.53. Minus is because here this one minus, not because of that force. FCD and FCE are the unknowns. Go for summation f of y is equal to 0 minus FBC plus FAC sin 26.57 plus FCD sin 26.57, because along y axis is equal to 0. Substitute the known values, you will get FCD as minus 5.63 divided by sin 26.57 degrees. So you got a negative value, so it is in compression. For this particular joint, use the same minus 12.58 and find out, substitute here and find out what is CE. Okay. So CE is 30.59. It is in tension because it is, you got positive. Our assumption is correct for CE. Okay. Next, moving on to the joint H. In joint H, see how the forces were. joint edge, there were one force here, one force here, one horizontal RHY acting here in the vertical direction. Okay, so for that particular joint, forces are in tension. Substitute, find out summation f of y is equal to 0. Along y direction FGH is minus FGH sine 20 sine theta. Theta is nothing but 26.57 plus 9.37 is equal to 0. So FGH is equal to 20.95 kilonewton in tension. Summation f of x is equal to 0, that is minus FH minus FGH cos theta is equal to 0. GH you have already found out, this one, substitute there, find out FFH. Last joint is E. In E, you have the joint E, that is here there are three forces, FED, FCE, FGE. So all the arrows are pointing outside, acting in tension. Summation f of y is equal to 0. Only one force in y direction, therefore FED is equal to 0. This is a no force member, zero force member. Okay. Summation f of x is equal to 0 minus FCE plus FEG is equal to 0. Therefore FCE is equal to FGE, which is equal to 30.52 kilonewton in tension. So there are two more joints which we have left out, that is joint D and joint F. Why we are considering it last? See, if you look in the figure, a joint F doesn't have many members. However, there is in joint F we have RFG, RDF. Yeah, RDF is unknown, so we did not touch the joint F. Okay, so first we'll go for joint D and then we'll move on to the joint F. So in the joint D, apply the conditions of equilibrium. Summation f of y is equal to 0, that is FDC or FCD in y direction, moving towards positive. Here is FCD, moving towards positive y direction, it is FDC sine theta. FDG going towards negative, so it is minus FDG sine theta minus 10 kilonewton. FDE we found it as 0 force, that is why we have not used here, though it is presented. This we found it as 0 force member, so we are not taking into consideration. No other forces in y direction, only 1, 2 and 3. You have written it here. Substitute the values, known values, find out FDG, but you got a negative answer, that means it is in compression. What we have taken DG as moving outside the, that is in tension we have considered, but we found that it is in compression. For this particular joint, still consider it as minus 9.77 and solve the problem, whereas when you go for next joint, if need be, take the change the direction. Next, apply summation f of x is equal to 0, that is FBD plus FDF plus FDG cos 26.57 plus FDC cos 26.57. So find out what is the unknown FDF. It is found in tension. Okay. So after that move on to the joint F. Summation f of x is equal to 0. F r fh minus r df is equal to 0. So you have found out what is df. If these both are equal, then it is these both are equal here. Summation f of y is equal to 0, that is r f g minus rfg minus phi. So rfg or ffg, it's written as rfg here, ffg is equal to minus 5 kilo Newton, which is found in compression. So the sign is different. So after finding out all the forces, please tabulate it like this and write down. If it is negative, write down compression. Positive means write down tension. So that is how we solve the forces in each member. So if you go methodically, systematically draw the free body diagram for each joint, referring to the given figure without doing any mistakes, you can arrive at this last tabular column. So usually you have to arrive till this, and please in each step mention the conditions of equilibrium, draw the free body diagram. The free body diagram has got is very important. Free body diagram is very important while solving any problem. So don't get confused, sit and do it systematically. So we are coming to the end of this video lecture. This is one problem for you to solve. So please draw the free body diagram properly and solve for this problem. Find out the forces in each member by the method of joints. So I close this video, end this video here. We meet you with another video for the method of sections.